Welcome to lesson 2.4. This will be the first lesson of the second trimester, where we are dividing polynomials. Let's look at the objectives. So for the objectives, a lot of this should look familiar. We're going to use long division to divide. We're going to use synthetic division to divide. So there's two ways to divide. Then we're also going to look at the remainder theorem, and we're going to talk about the factor theorem. Factor theorem is probably the thing that is the most new, although we did use the factor theorem, just maybe not in explicit terms last year. So the first thing we're going to do is do some long division. When you set up the long division, the divisor is on the outside, and what you're dividing goes on the inside. So you just look at the first term of the divisor and the first term of the dividend. What is x squared divided by x? You end up with x. So then that's going to go up here, and then you multiply. X times x is x squared. X times 3 is 3x. Then you subtract. X squared minus x squared is 0. 10x minus 3x is 7x. Really important to subtract and make sure you're subtracting this term. That's where almost all the mistakes happen. Then you bring down. X goes into 7x, or in other words, what is 7x divided by x? You get 7, right? So it's plus 7 here. 7 times x is 7x. 7 times 3 is 21. And you get 0. So that means x squared plus 10x plus 21 divided by x plus 3 is x plus 7. No remainder. I'm going to leave part B for you to try on your own. So pause the video. I'm going to work it out while it's paused. And you come back and check your answer. So you pause it, try it yourself. So now that it's worked out, when you divide by x plus 9, you do get x plus 5 with no remainder. Let's take a look at the next example. So this is what's called the division algorithm. If f of x and d of x are polynomials, and d of x is not 0, the degree of d of x is less than or equal to the degree of f of x, meaning the thing you're dividing by has a degree that's less than the thing you're dividing. Then there exist unique polynomials q of x and r of x such that. So f of x is going to be equal to whatever you're originally dividing by multiplied by whatever the quotient is, plus whatever the remainder is. Right? So essentially there's just an algorithm that's talking about what we just did. Right? So f of x was the original, d of x was the divisor, q of x was the quotient or the answer, and then the remainder, in our case, was 0, but you could also have a remainder that's added in. The remainder, r of x, equals 0, or it is of degree less than the degree of d of x. So the remainder needs to be a degree that's less than the divisor, or it's just 0. If r of x equals 0, then we say that the divisor, d of x, divides evenly into the original function, f of x, and that d of x and q of x are factors of f of x. So that'll come into play when we talk about the factor theorem later. But basically what it's saying is, if there is no remainder, then it divided evenly, and the divisor and the quotient are factors of the original. We're going to do some more long division. So for the first one here, 3x minus 2 is the divisor. What you need to do is you need to put this in descending order. So I'm going to reverse it. So 6x cubed minus x squared minus 5x plus 4. 3x goes into 6x cubed. write it out if you need to write it out. You end up with 2x squared. So that's going to always line up by degree, part of the quotient above the dividend. 2x squared times 3x is 6x cubed. By the way, this always happens. If you did the dividing step correctly, this part will always subtract to 0. Then 2x squared minus 2 is going to be negative 4x squared. Now when you subtract, that's 0. Negative x squared plus 4x squared is going to be 3x squared. And you're going to bring down the negative 5x. 3x goes into 3x squared, and write it out if you need to write it out. 3's cancel, and you're left with just x. So then plus x. X times 3x is 3x squared. X times negative 2 is negative 2x. Now when you subtract, 3x squareds cancel out. Negative 5x minus a negative 2x is like negative 5x plus 2x. So negative 3x. Bring down the 4. 3x goes into negative 3x, negative 1 times. Negative 1 times 3x is negative 3x. Negative 1 times negative 2 is plus 2. So now when you subtract, that subtracts a 0. 4 minus 2 is 2. So this one does have a remainder of 2. Okay. For the next 3, I want you to try them on your own, and I'll work them out. So pause for part B here. So this one ends up being 2x squared plus 3x minus 2 with a remainder of 1. Same thing with part C. Pause it and come back and check your answer. Little trick on this one. If you don't remember from last year, you need placeholders. So you need that 0x squared there to work it out. And this one works out a little differently where the remainder is the entire 7x minus 5. But based on what we talked about with the division algorithm, as long as the remainder has a degree less than the divisor, should be okay. All right, let's take a look at the next one. There we go. All right, so you pause it, try it, and then come back and check your answer. All right, so this one ends up being 4x squared plus 11x plus 22 with a remainder of 37x minus 10. All right, so let's take a look at the next example. We're going to talk about synthetic division. This is way better. If you recall, whatever the divisor is, basically take the opposite of whatever's happening to x. So negative 2 is going to be the number in the box. Then I list out the coefficients. Notice how there is no quadratic term here. I need a placeholder of 0, and then 6, and then 8. Drop the first number, and you multiply. Negative 2 times 5 is negative 10. Add down, and then repeat the entire process until you're done. Negative 2 times negative 10 is 20. Add down to get 26. Negative 2 times 26 is negative 52. And then you add down, and you get negative 44. And then you just put it all back together. That's the remainder. Almost think about it right to left. The remainder is negative 44. Then 26 is your constant. Then negative 10 is the coefficient of your linear term. And then 5 is the coefficient of your quadratic term. Now you try it, pause it, try it, and then come back and check your answer. So this one actually worked out with no remainder. So it's just x squared minus 2x minus 3. Let's take a look at the next thing. So remainder theorem. If the polynomial f of x is divided by x minus c, then the remainder is f of c. So the way that we can use that then is it's basically the reverse. If we're being asked to evaluate, what we can do is divide it, whatever the remainder is at the end, ends up being what it would have been if you evaluate it. So take the number. It's not the opposite like you're doing with the standard synthetic division when you're given a factor that you're told to divide. So this is, you're going to take 2, put it in the box, list out the coefficients like we did before. Do everything the same. So drop the 1, 2 times 1 is 2, add down, you get -2. 2 times -2 is -4, add down, you get 1. 2 times 1 is 2, add down, you get 5. That's what we cared about. So what this is saying is, if I evaluated the original function for 2, I would get 5. All right, so let's take a look at the next example. So again, pause it, well, try it, pause it, try it, and then come back. So after doing some long division, you get the remainder of -105. So that means f of -4 is equal to -105. So let's take a look at the next example.